Okay, good afternoon everyone and welcome back to the education track. I expect there may be a few people still making their way in, but we are going to start. We do want to stick to time. So our next presentation is by Renee Noble. Now Renee is the Executive Director of the Girls Programming Network and a software developer at Grok Learning. And having had no exposure to programming until stumbling upon it while studying at Sydney Uni, she was quick to add a CS major to her chemical engineering and chemistry pursuits. Now, while at GPN, Renee has taken what was a small side operation to providing 500 girls a quarter with free programming workshops all around Australia. So there are GPNs in Sydney, Canberra, Mackay, over in WA, and there are more on the way. But to talk a little bit more about how they take concepts from ideas all the way through to classroom activities, I'm going to hand over to Renee. And as soon as she does that... Okay. There we go. Does that look pretty good? Excellent. All right. So she was actually doing that just to wait for our next group of attendees. That was beautifully done. Renee, take it away.
Okay, here we go. Thank you for coming to my talk, Concept to Classroom. I'm going to tell you some things that I've learned along the way about taking an idea to something you can actually run with kids in the classroom, from the lessons I've learned and the problems I've encountered along the way in making my own projects and the things that I've seen other people make. Feel free, there'll be a link to the slides on the Twitter later. Up there. So, yes, I'm Renee. I'm a software engineer, I'm an educator, and I like making communities of people where people feel included and excited about something. I work for Grok Learning most of my time, and the rest of my time I spend running the Girls Programming Network, and I'm also supported by Data61, who helped me have time to run GPN and pay rent. Yes, so I'm going to tell you about what we do at GPN, the Girls Programming Network, a lot today. We've run free programming workshops for high school girls predominantly and some talented upper primary students, and we focus on an authentic programming experience. It's all run by women and people of gender diverse groups, and we have a whole range of students from complete beginners to kids who've been coming to GPN for 5 or more years. Some of them are in the room right now. And we're really about creating a program that eliminates barriers to entry. You don't need to know any programming to come along. You don't even need to know that you don't know any programming to come along. So you can come along, and it's a full pipeline support. Whether you're a tutor who wants to get involved or a student who wants to get involved, you can come along and join the community. We operate on 6 main values to kind of summarize the vibes we're going for. It's about more than just kids in a room at computers doing the codes. It's about finding friends. It's about, so it has to be challenging, of course, to get that authentic programming experience. But we also want it to be fun. We want it to be social, about making friends, meeting people who are like you, especially if you're a girl and you might be the only girl in your school interested in technology. And also you want to be able to find people who are like you but older. So we have all our amazing tutors who show you the kind of people you can be in a couple years from now. So it's not just being like, one day you could be an astronaut if you really, try. It's like really about having those tangible role models. Next year you could be this person. They just did this high school subject and now they're at uni doing this thing. Or in 5 years you could have this job. You just have to be this person and then you can become this person. And then, the sky's the limit after that. You can be an astronaut if you so desire. But yes, all the steps of the way are represented. We also see this because we have such a diverse range of tutors and students in the room. We're about creating an environment that's for all girls, not just for nerdy girls and people who identify as super techie. Whether you love, horses or playing the tuba or rock climbing or dancing or baking, coding can be part of your identity. It doesn't need to be the whole thing. So we have a whole range of tutors who show that they're more than just coders. Finally, we have the network. It's about creating those friends who you can't wait to see next time you come back to GPN. It's about meeting those mentors who you can't wait to be. And it's about connecting with people all around Australia who are excited about technology. In these locations, these are our 6 GPN locations so far. And something we've learned from having spread this program around is that we're encountering a whole other range of students that we hadn't encountered in metropolitan Sydney before. So we've got people out, in Cairns and Mackay who, getting together in a classroom on the weekend to put on one of these events because they're also excited about technology. But we're needing to support a whole different range of students and tutors to engage with the program. To tell you the scale of the program, we have between 20 students maybe at a Cairns event or 180 students per workshop at a Sydney event, and we had so many that wanted to come that we had to make it 2 days so we could have 2 separate workshops so we could have twice as many students. So there's a whole bunch of girls who are super excited to learn to code from a whole range of backgrounds. So along the way we've encountered a lot of feedback from all our different nodes helping us improve our content so we can include more people. So what have we seen? So what do we actually do to include everybody, and what activities are we actually doing? I've told you we're doing coding, which is cool, but what do? We're doing project-based learning. So when we advertise a GPN workshop, we tell them the topic of the workshop because that's how we're going to get someone excited. They go, I could build a scissors, paper, rock game, or a Flappy Bird, or a cookie clicker, or I could build a Caesar cipher. And it's something that they've gone, I want to build that. That sounds exciting, rather than just come along and do a code with us. Which, if someone's already in the club, they're going to sign up for. But if they're not there yet, you've got to excite them a little bit. But the thing is, we've told them what they're going to build, but we have literally no idea how much coding they know coming in. So we've said, come along, and we're just going to sort you out. That's our low barrier to entry process. And then we need to work out how to deliver the same project goal for a complete beginner to someone who's been coming to the program for 5 years. So how do we do that and make sure everyone ticks that box and I did the thing that I signed up for? So I'm going to tell you today about how we've designed our projects with differentiation to enable that. So along the way, I've met a lot of people in a lot of different contexts who are excited about making projects for kids. And these are the kinds of things I believe people think about creating projects for students. They go, well, kids only want to have fun. They don't want to do the hard things, or they only want something that looks amazing. So I come up with this very scientific chart that I drew earlier about where I kind of hear people going, this is what we think we should be doing in the classroom. And these are people I've seen at competitions being like, this is what I want to teach my kids next, or students making requests on what they should be doing, and people designing projects for schools and other activities. So on one end, we have the kids just want to play and not do the hard work to make something happen. So these are the kinds of projects where someone's gone, we have an hour to engage in technology. So I'm going to go and get a VR headset, and we're going to have the students take turns at watching a video of the haka wearing the headset, which is like, if I was going to watch the haka, that's how I would want to watch it. But this is not how I tick the technology engagement box. So we've got people flying drones for 20 minutes and not actually building anything. They've touched the technology, but they haven't really learnt anything yet. It's also something you might see if the teachers themselves don't really engage with technology themselves, and they don't know how far it could possibly go and what you can do with technology other than use it like everybody who has technology in their house. So that's on one end of the scale. On the other end of the scale, we have not necessarily someone starting out with we're going to have to do a really hard project. They often think it's not as hard as it looks. So I hear a lot of, the code's not that long, so the kids can definitely do it. And I'm going to show you how that can set you up for a problem in the coming slides. But yes, these are the ones people who say, well, no one's going to want to do it if it's not flashy, if it's not fully featured, if it doesn't completely work down to every last bit. If it doesn't have a GUI, what are we even doing here? So I'm going to show you how we can do cool things without a GUI that are engaging and exciting and not that hard. So here's how I think we should actually think about teaching kids to code. It's not just about fun and having a really awesome thing that works at the end of it. We have the accomplishment, achievement factor in the middle here. And it's where you get to tick off small boxes along the way, and you know where the thing works and where it doesn't work yet. So I hear a lot of girls at GPN go, hey, look at this. My program does this awesome thing now. And then the user, usually mum or dad comes in to use it at the end of the day and is like, no, not that, stupid. It doesn't do that yet. That's not what my project is about. because they know what happens now and what's going to happen later when they add in more bits. We've got like a simple program, and if the adult who's using it makes a typo or puts in a capital letter, they know that it's not going to work. And isn't that amazing that they can tell you down to the character how their program works with only a few hours of experience? So they get this full understanding of how maybe a shorter text-based program works. It doesn't need to be flashy for them to be excited about how it works and about telling their parents how it doesn't work and how they're stupid. Now on the other end we have the thing where they didn't really do a thing. The kids know when they didn't really do a thing. They had fun for a little while, but that's, good and all. But you don't want to, spend all your time just having fun where you're not really building anything. You could just go to the shop and you haven't done anything unique. On the other end, we have the students who didn't really get what they were doing because you've run out of time in the day to fully get through the concepts you're trying to teach. You've gotten to a point where you're like, oh no, they've only got an hour left in the day and they've barely got, if statements working, and we've got to get through for loops, some functions, and a whole bunch of GUI stuff before it looks anything like what I promised them. So you just push them through and you end up with paint by numbers code, which they don't understand and don't feel like they've, built themselves. And this is mostly problematic when you're dealing with students who don't feel like they're in the club, because they're going to go away at the end of the day feeling like they don't belong and they shouldn't have tried in the first place. And with your project, you've tried to include them, but by making it too hard, you've actually proven the stereotypes that girls especially don't belong in coding. So the dream is this point for every student. We want every student to reach their peak, but every student's peak is a different point, which we've heard about today earlier in Ben's talk about hitting that area for working out what they already know. So how do we hit the peak for every student? Well, we're going to start with a minimum viable project, MVP. Everybody knows that. I'm just stealing some words. So to make your MVP, you're going to have to start by looking at what your constraints are for your group. Who is in your group? How old are they? How engaged are they? Have they chosen to be there? Luckily with GPN, they've all chosen to come on the weekend, so they're super excited about doing something. But if you're in a high school maybe where they're forced to do something, you're going to have a few different constraints in terms of engagement. We've got your ability range. Are some complete beginners? Are some super on the other end and know a lot of stuff? How much time and support do you have? At GPN, we have 1 tutor to every 3 or 4 students, so we've got a lot of support. But we also only have 3.5 hours, so it's factoring in all these different parts. Once we've got those down, we need to design an MVP for our system. You need to start at the bottom. People go, well, I've got this awesome idea and then I want to get to that, but maybe we could just do an easier version. I'm going to tell you, you need to start the other way around. What's the smallest thing that you can build to tick that box? Because it's always going to be easier to add fancy, shiny things on later, but getting something pared down to the simplest version is often impossible if you started with the incorrect project. So think less is more, and we're going to whirl our way up. Finally, once you've decided on a project that works for your context, we're going to differentiate it by adding extensions and diversions to distract your more speedy students whilst also teaching them something but not worsening your problem. Okay, so we're going to start with our beginners project. At GPN we have 3 levels, beginners, intermediate, advanced. Start at the bottom because we want to make sure they've ticked the box. Everyone else, it's going to be easy to tick that box of whatever we've advertised, whether it's cryptography or making a game. So we start with the beginners and then we go, how can we do this maybe with harder concepts instead of just using a lot of variables? We're going to use some lists or a dictionary. We're going to turn it into functions. So how can we make the same project or build on the original project to turn it into something more complicated? Next, bonus activities. These are the diversions I told you about. So along the way, you might want to have lectures in your classroom and you want everyone to be at a similar point when you give those lectures. With this, we're putting in things that shift the students sideways rather than giving them more knowledge that will actually worsen the problem and speed them up even further. So these bonus activities might be like, now change your thing from plain text to have ASCII art pictures when you print out something. Or maybe we're going to add in some sleep so it looks like the computer's taking a long time. Little bits and pieces here and there that slow them down, giving the other students a chance to catch up. Finally, you can just put as much stuff as you want on the end. yeah, there's just infinite extensions to everything. Just write them all out, and the kids can either do them there if they've done everything and nailed it throughout the day, or take them home, because if they're excited, they might go and add more on to their project. Okay, so that's what we got to do, yes? But how is the real question. I've just told you how to make 3 different levels of projects, but you just do it. Here's my way of making these 3 different levels of projects with the 5 C's of content creation. I got very excited with the thesaurus. They all start with C's, but you got some extra bonus C's throughout because I was generous. So we're going to start with contemplating your cool concepts for your context, like who's your students, what do you want to make, why. Code, calculate, and code again. I'm going to show you something we've developed at GPN for actually working out how hard a project is for your specific level before actually inflicting it upon any children. Because sometimes you're just wildly wrong or you've just missed a bunch of concepts. So we'll have a look at how you can quantify what you're actually doing. Then we're going to look at how you can break up that project into a pathway from no code to a final working project, and then all the extensions you want to add along the way. Then we're going to see how we can make that into booklets that students actually want to read rather than what they want to not read and just pretend like they're doing the work. And finally, how can we look back, improve, iterate, and do better the next time? So firstly, we're looking at our class, our group, wherever you are, and how are you going to engage this group? Is it specifically you know, girls? Is it kids who really like science? They're really into a specific thing. How can you best pick their interest to do this project? Don't go and make up something like, sometimes people go, I really want to teach this technology, and then you make up a narrative that's contrived just to fit it in. The students will know, and they'll be like, this is pointless, and I don't really want to do it. And also having a narrative that doesn't really make sense makes it harder to interpret how to apply code to this situation. Now, once you've got your idea down, work to that MVP. Think about what the smallest project would be and what's the more extensions you would add on to it for your more experienced students. What's the range, or is it a very fixed area? And think about how that suits your cohort. Okay, we've got our idea, and we're going to start at the bottom with coding our beginner's project, because often I go, this sounds like a terrific idea, and then you actually sit down to code the thing and you're like, oh, I've got to need this list. Oh, this has a lot of edge cases. That's a very long if statement now. Oh, this is getting a bit awkward. So by the time you finish it, you're like, this isn't as easy as I thought. I thought it may be an if statement, a loop, input, and we'd be done. But often it gets a little bit harder once you actually put it into practice. So we start by coding our thing, and then we use our calculator to quantify the challenge of this activity for the group that we're looking at. So here is the calculator that I've come up with by looking at lots of different GPN projects, how they went in practice, what was hard, what was easy, and what are the concepts that are easy to grasp onto, what takes a lot of time to explain, like variables. You need them, but you have to spend a lot of time on them. So these are all effort points for the different concepts you might use in the classroom. You'll notice that you start to get some for free in the more advanced classes. You just kind of take for granted they will know how to do a print. It's not going to take a lot of time. Just be like, chuck in a print and they'll be fine. Cool. We've also got some extra ones. So those previous ones were all about Python and the things that you're using in the code. But here's some ones you might not realize that are there. Things like nested if statements or loops. That nesting factor takes a little more time for them to explain. There's a lot of places that things could go wrong if you don't have it nested. It's a hard thing to explain in the classroom. We also got like long code. It's useful because they get lots of chances to practice, but they also have tiny hands and are very bad at typing. So we need to add just this little bit more time if we're having to type something really long. And also any sort of creative decision takes it forever because they're like pink or green, pink or green, pink or green for 20 minutes. And yes. So we've got to allow time for those things, and we also have to allow time for any concepts we want to explain. Things, when we're making a game, I'm going to give you an example of how we've used this system, of how we did tic-tac-toe, and that's something they already understand. But if we want to teach something like cryptography, it's not something that they inherently already understand. So spending time, maybe doing an unplugged activity to communicate the concepts they're about to code takes some time out of your day. And also, if you're using any additional technology, as we heard Jack say earlier, microbits, they're distracting. Any hardware is distracting. All those kinds of things can take time out of your day. So once we have put it through our calculator, we see the score and we go, is this achievable? Do we need to recode it? Or maybe this is good for intermediate. How can we work it back for something we could use with beginners? And then finally, we reiterate on that for a while until we get something we're happy with and we go, yes, that's a good place to be at. And then we write what we call at GPN a breakdown. So we take the code that we want to get to and we go, how can we build this in a pedagogically friendly approach? We want also for everyone to be able to say they've built a new thing at each step of the way. So that way we can be like, we're adding the part where we check for a winner or where we play multiple turns of a game. So that way they know what they're building, because when they know what they're building, it's much easier for them to understand and put the code together. In this system, we also add places for extra practice. So say we're playing a game of tic-tac-toe and we need them to ask what place do you want to play in. We could also add some places for practice at the start, saying like, what's your name? What's your favorite color? Just great places we can practice the same concept so it's fluid when we want to use it in the project. Okay, we've now made our plan and we want to put it into something that the students are actually going to see. And when we do this, we want to follow our breakdown and create engaging materials. So we want to make sure it's formatted nicely, it's about colors, it's about headings, it's about drawing attention, because students, they hate reading. They don't like long things. I don't like reading long things either. So we're going to grab their attention, keep it in the places we need, and make sure it's child-friendly, short, small words, and only using relevant concepts for the project. Because if we teach them something and then don't use it, it's definitely gone forever. Also, avoiding spoon feeding is great. So if we're spending time only on the concepts we need, then we don't need to brush over those harder concepts that we might lose time for otherwise. So they actually understand all the code that they're writing. Okay, we've now built our project. It looks amazing, and we've delivered it to the students. We want to see how it actually goes in practice, and which concepts work well, which were harder to teach, and if there are any tricky parts that need an alternate delivery method. Sometimes we go, this is a great project, but they just get stuck on these 2 dot points that we want them to do. And sometimes something like a code along where they type with you will get them over those humps, which means there's a whole range of projects you can now do, which is still exciting, challenging, but you don't trip them up unnecessarily for no reason. Okay, so here is an example of how we made tic-tac-toe using the 5 C's. So we thought, what do we like at GPN? They really like games, and text-based games are really fast to get up and running. You can play with your friends because the rules are well known, so that'll be easy to get them through. And it's not like it's a gendered game. No one's like, tic-tac-toe, that's for boys. So there's no stereotypes at play there, so we can have that hurdle of getting people in the door. And with tic-tac-toe, it's a really simple game, but there's lots of implementations. So we can just build a super plain game, or we can add a whole AI, which will make our advanced students do in this project. So this is my first version of the code that we wrote. I'm like, cool, thinking about it, what would I do to make tic-tac-toe? It's got like a list, then it's got some if statements, it's got a while loop to keep the turns going. In this one, we're like, we change symbols so it keeps track of whose turn it is, and yeah, and we decide who the winner is. So we put this through the calculator, and this is how we do the calculator. So we go and find every different concept in there, and there's often ones that are hiding in there that you didn't realize, like things like int input. That's 2 concepts right there. That's like 9 characters, 2 concepts that's going to be a while in like lecturing and things that you might not have realized because it's so short in Python. We've got a bunch of list indexing, which is tricky. And then we've got, a lot of if statements and things, which is good for practice. And yeah, a lot of concepts going around all over the place. What we got was 69 points. And 69 points might be useful for your classroom if you've got a couple of weeks or things like that. But for us, we only have about 3.5 hours in the computer lab, and we go for about 50 to 60 tops concepts. So what did we do? We calculated it again. We went, what could we do that makes this easier? What concepts can we get rid of? Well, don't we need a list? You know what's better? 9 variables. So, yes, when we're coding, we don't want to code like a pro, we want to code like a child who only knows variables and if statements. So that's the goal. We knocked out lists. That also meant we didn't need indexing, which meant we didn't need numbers. So we're also able to knock out the int input, and we just have the input and everything is referenced by a string version of the number. So also we knocked out 0 indexing, so we didn't need to do that anymore. One less concept explaining why we start counting from 0. So now we have this code. We have no lists, no int, and more practice on variables, and lots of practice on if statements as well. So now we're practicing the things that they haven't ever done before without introducing all these extra things to distract them and that they won't understand. So we had our code, we turned it into a breakdown. So in each step of the way, we have different parts of the project being made. We're starting the game, we're printing a blank board. We're asking a question, what player are you? And what position would you want to go in? Also note something about this code is we decided to get rid of the part where you change turns. And this game, we also just say, who are you and where do you want to go? So that's another thing we've knocked out there. So we've added asking who you are and where do you want to go, 2 questions, easier to practice. Then we're going to add those to the board using our many if statements to work out where you've gone. And then we're going to add in the loop, so you can have multiple turns, and then you get to pick the winner finally. So the reason we put it in this order is we get to attack those different concepts in a pedagogically friendly order, starting with print and variables and string operations, and heading on to if statements and loops, and then finally finishing up with the harder, complex and or operations to kind of work out the winner, which can be a bit tricky. So hitting them in easy to hard order. Then we looked at some parts for some bonuses and extensions where we could add those in along the way, and we can see that it's ready to turn into a workbook. So these are things from the actual tic-tac-toe workbook. We can see they're really colourful. That's how all the GPN workbooks look. Colours with hints and checkpoints. It turns out if you don't tell the students to run their code, they just simply don't run their code. And they're like, step 4, like page 4 of the project, it doesn't work anymore. And you're like, well, did it work in this step? And they're like, don't know, haven't run it yet. So we've added in all these checkpoints that say, does it do this when you finish this? Or does it, do this when it runs? So you can check along the way. We've got these by hand examples, so they actually have to engage with the workbook so they can see that the workbook's something you're supposed to use when you do the project. And also we've got this fun algorithmic worksheet which is telling them how to do a min-max tree for the advanced students. So teaching recursion. This is my baby. It took me 8 hours to make this one sheet of paper. But it was worth it for the 3 children who did it. Okay, so we then ran it in the classroom and it went pretty well, I thought. It had mostly engaged everybody. And most of the students got a lot of the way through. But there were some things we learnt along the way. Like printing a blank board doesn't really make sense when you're using variables. They're like, why would I add in an empty, like a string that's just got a space in it when I could just print out a blank board because I know how to do that. So we're like, maybe for this scenario, we could give them another example where they need to figure out what kind of board they're going to print. How would you print XXX, XOX, and get them to put in the variables so they can figure out how the variables actually interact with the grid. This linear set of numbers needs to get inside the grid somehow. And also, you know how I said we got rid of the part where we switched turns? Getting rid of that code to keep the code shorter? Turns out they really don't get that. Taking turns is so intuitive that removing the extra code actually made the project harder because they were like, but when's it the other player's turn? And we're like, well, you're asking every time whose turn it is, but they didn't understand that part. So actually adding in more code in this section could be beneficial because of the intuitive nature of tic-tac-toe. So this is how we made this project. We did this for beginners, and for intermediate we had this, basically the original code, and then finally advanced to the intermediate and also that fun extension with the AI that played against them. So this is how you can use these concepts in your classroom or wherever you're teaching to scale a project to your timeline and a level of ability, calculate how hard something is before you actually have to run it, and create a coding journey that gets them through the process. Yeah. So I hope you try it. These are me. You can send me things, and yeah, the slides are there. I'll also be on my Twitter later as well.
Thanks, Renee.
Yay.
So we're now into change over time. So if you were planning to shift rooms for the next